Welcome students to another lesson. In today's class we will be looking at phasor and vector diagrams. Okay, so we will be looking at, let me just write the heading here, phasor and vector diagrams. So like I explained before in the previous class, you know that your inductor, so this topic that we're focusing on is from the chapter RLC circuits, right? So we know that your resistor follows normal path, and then your inductor, it is, so your inductor, let me put it in red, your inductor is lagging, right? So inductor is lagging, so it's going to be positive um, positive 90 degrees, right, on the sine wave. So this is typically your sine wave, right? So it's going to start at positive 90 degrees, whereas for your capacitor it is known as the leading, right? Leading, it's leading, but it's going to be negative 90 degrees, and that will look like something like this, starting from negative 90 degrees. So the topic that we're going to focus on in this class is phasor and vector diagrams, right? So there's two ways where you can remember this. The first is from diagram and the second is from the equation. So let me explain both methods. The first method, if you want to remember it this way, you have your x and your y, right? So on your x axis, you guys know this is your x axis, that's your y axis. So on your x axis, this will be your real numbers, right? And then on your y axis, this will be your imaginary numbers, right? So what is an imaginary numbers? I won't explain it to you in this chapter because it's kind of a long thing to explain, but basically it's something to do with the square root of negative 1, right? So this here will be your imaginary number, right? And then the square root of your imaginary number will be -1. That's just something that you should know. Other than that, I don't want to go into details about explaining to you, it's gonna get you confused, but so long, just remember that this is an imaginary number, right? So coming back to this, all your real numbers are going to be on the x-axis, and then anything that goes to the y-axis is going to be your imaginary numbers, right? So that is one way of remembering your vectors and your phasor and vector diagram. We're going to get to that topic, but just to understand that better, you have your imaginary and your real numbers, right? Real numbers and imaginary numbers. Okay, so the second method, so this is method 1, let me write here number 1. Your second method, so number 2 would be from equation, right? So from equation, so what equation do we have? We know that the impedance, right, is equal to the resistor plus, open bracket, resistor of the inductor minus the resistor of the capacitor, open brackets, and then your imaginary year. So this here is known as rectangular form, and I did this in the previous class. And then after that you would be asked to convert it to polar form. Polar form. So you can either be given polar form or rectangular form, right? So polar form would be basically z is equal to, you will have hypotenuse and then you would have angle theta. So what does that mean, right? So in your rectangular form, right, you have your x, which is your real number. So this here is your real number. And then you have plus your y. And this will be your imaginary number, right? So when we come to the graph that I drew over here, this graph. So when I look at the graph, we have an x value and we have a y value, right? So when we connect these 2 points, we are given h, the hypotenuse, right? So we can use Pythagoras theorem, right? Or we can use trigonometric ratios, and then we can find the angle, or we can calculate one of the sides, right? So this is our rectangular form, right? And then our polar form, which is going to give us, is going to be the hypotenuse and it's going to be angle theta. Okay, so just a quick reminder, it's going to be a squared plus b squared equals c squared, right? You can use that. And then there's also SOHCAHTOA, or I like to write it like that. Okay, so I like to remember it like this. And normally we would use tan, so we would have tan theta is equal to opposite, which is y, and adjacent, which is x. So then theta is going to be tan to the minus 1 y over x, and we get our y from here and we get our x from there, and that's how we are given the angular to get rectangular and polar. Also, I explained in the previous class how you can use a university calculator to calculate your answers, but if you are not given that calculator, then you would have to do it manually and work out each step. That's not a problem. That should not be a problem to anyone. But if you do have a calculator that can do it for you, um, you should also practice it by doing it without the calculator, just in case anything happens, right? Okay, so now remember I said that there are two methods, right? There's this one and there is the equation method, right? So let's look at the first method of the diagram method, right? The diagram method, right? So the diagram method says that these are your imaginary and this here is your real, right? So for your first diagram, you're going to have your resistor on the x-axis. So here's your diagram. This is your resistor in ohms, right? And then what we have here, if we can just copy this here, copy in case you forget in exam room or for whatever reason, so we copy here, we paste it here. Okay, so it's saying over here it's saying positive or I and negative or C, right? So if you are having a problem with that, um, let me just take out the calculator quickly. I want to show you guys what I'm talking about. Um, so let's say we're given AC. So we are given positive or I, right? So let's say positive 10, right? Shift. Don't forget about your imaginary, right? So we got imaginary J, right? Don't forget that imaginary. And then coming back to the calculator. So we have 10, shift, imaginary, okay, shift, imaginary, right? So then we're going to press shift 2 and we're going to press, we want to convert to get an angle. And you can see that the positive is giving us positive and it's giving us an angle of 90 degrees, right? So if we make this negative 10, right? Where did I get the 10 from? It's just an example, guys. So the negative 10 is going to give us, we're more focused on the angle. So the negative 10 is going to give us negative 10 is going to give us 10, but it's going to give us negative 90 degrees, right? So then we know, so let's get back to the question. Let's get back to the explaining. So we know that our resistor is going to be on the x-axis, which is your real numbers, right? Then on your y-axis is going to be your imaginary, right? So we got inductance being positive, right? So Ri inductance is on the positive side, and then Ri sorry, or capacitor is going to be on your negative side, right? Okay, now moving on, we look at our voltages, right? So we have our voltages, so we have our supplied voltage here, which is supplied, which is our real voltage. Then on top, right, Ohm's law, right, our voltage is equal to our resistor multiplied by our current, right? So for our voltage, we're going to write it as our voltage is going to be, for inductors, going to be on top, and for capacitors is going to be at the bottom, right? Reason being, right, is that when you multiply I and R, you should get a positive answer or a negative answer, right? So now we'll be looking at the, okay, let me explain to you. So when you multiply negative, you get a positive, and a positive multiplied by a positive, you get a positive, right? And a negative multiplied by a positive is a negative, and a positive multiplied by a negative is a negative. Yeah, so that's just a few of the rules. But for the current, it's kind of different, right? So for your current, it's going to be slightly different, where your real still remains on the x-axis. So this is your real current, right? And then your inductance becomes negative and your capacitor becomes positive. um, I explained in the other class, in the previous class, um, the reason for that is um, the reason for that is, so for voltage, okay, let's look at inductance, right? So resistor is on top, right? Positive. For voltage, inductance is on top, which is positive. But for inductance, for current, it's negative, right? And you can see that capacitor is negative. Capacitor is negative, but for current, it is positive, right? That comes from solving division. So when you do a division, um, problem, right? So let's say you're given positive, positive, right? So you're given r plus I, r plus I, right? So then you're given a positive, you have to multiply it by 1, because anything multiplied by 1 is equal to itself, right? Anything multiplied. So 1 multiplied by 1 is 1, 100 multiplied by 1 is 1. Oh, sorry, 100 multiplied by 1 is 100, 200 multiplied by 1 is 200, 3 multiplied by 1 is 3, 4 multiplied by 1 is 4, 5 multiplied by 1 is 5. So anything multiplied by 1 is equal to itself, right? So then what you do is you invert it, right? So you have r plus I multiplied by r minus I. Okay, let's make this z here so we don't confuse ourselves. Over r minus z. So this way we will get we will remove the denominator. Remove denominator, right? And that is our goal, to remove the denominator. And then we will be able to solve our division. I did this in the previous class, and also I did it with the calculator. So if you're not sure, you could see the notes about division, attraction, addition, subtraction, and multiplication of complex numbers. So now that I explained that to you, I hope you guys took note of all of this, especially over here, just in case you forget. That's very important. So now, since we have all of that, something that might throw students off is if I am given current, right? So for current, it's kind of inverted, right? The capacitor is on top, right? And the inductance is on at the bottom, right? So, and this is the real, right? So what will throw the students off is that they would overlay the voltage as well. So what they would do is they would overlay the voltage on the capacitor, right? So then you would have your real here, that's your real voltage, and then you would have your on top you would have your inductors, and then at the bottom you would have your capacitor. But most importantly, students, you should not forget, most importantly, guys, do not want you to forget, don't let don't let all these rules for for complex numbers and inductors confuse you, right? What I want you to remember is that once you're solving for um the complex and your real numbers and everything, right? Once you're solving for everything, you would be given the values, right? If you did all your calculation correct, you will be given the value, right? So now what I want to explain is the phasor, which is most important, and the vector diagrams, right? So that's just the rules, right? But most importantly, you should know how to draw them. So what you would do is basically the phasor. So let's start with the phasor. The phasor is, it's going to include is going to include all values, and it's going to include all angles, and sometimes it might include the total and the angle, right? So what do I mean by that? So let's say you would be given, for example, I1, I2, so I1, I2, and I3, right? And then you find that your I total is over here. So this has an angle of 0 degrees, this has an angle of negative theta, and this has an angle of positive theta, and this has an angle of positive theta, right? So now you understand, right? And then number two is our vector diagram, right? Vector diagram. So the vector diagram is the same as phasor diagram. But you will have you will have to follow you will have to follow head to tail method, right? Head to tail method. So what is head to tail method? Remember Pythagoras, right? So you have your x, right? So here's your head. Let me get a red one. This here is your arrowhead, right? Your arrowhead, and this here is your tail, right? So head to tail method. So then you're going to draw your y like that. So you see, here's your head and there's your tail. Head to tail, head to tail. So head to tail, right? So that's your y. And then you can draw from your origin, you can draw your hypotenuse. So what does that look like? So for instance, if you are given, let's say, voltage, right? So remember I said that they're going to overlap this, right? So if you wanted to draw, let me just move this up a little bit. Move it there. Okay. So now we're going to draw so this is a phasor diagram. Let's draw a vector diagram, right? So vector diagram says it's the same as a phasor, but we're going to have to follow head to tail method, right? So then we're going to have let's do this, our supplied, right, v, right? Then we are going to copy. So you see this one, this will be our VR1, right? VR1. So we're going to draw that VR1, right? Then we have this one over here, right? This is called our inductor, right? So we're going to draw that VIND2. So this is VIND2, right? So we are following head to tail method, right? So there's your head, it's going there to the tail, there to the head, and there to the tail. And now we are going to draw VCAP3, and then VCAP3, and that all gives us the hypotenuse, but it won't be hypotenuse here, it will be your voltage supplied. And that's basically how you draw your vector diagram and how you draw your phasor diagram. And all these values as well as the angle will be given to you from your calculations, right? And you should know how to convert from your rectangular and your polar form by using either Pythagoras or trigonometric ratios. And that will be the end of the lesson for today, and hopefully I would see you in the next recording.